Right, in this video, we're going to look at how to convert from rectangular to polar coordinates. And we're going to use some of the information that we learned when we were looking at angles of rotation. And so we know that in a rectangular coordinate system, our points are in the form of x, y, and in polar, they're in the form of r theta. And so we've got this relationship here. X equals r cosine theta, and y equals r sine theta. And let's talk about where that comes from. So let's draw an angle. Just draw one in the first quadrant. Now these angles can be in any quadrant. Right, here's my theta. The point that we're talking about lies on the terminal side, which is the point would be xy. And we know from back when we were looking at right triangle trigonometry, we know this distance here is y. This is x from here to here. And we know that the cosine of theta is equal to x over r. And if you multiplied both sides of that equation by r, you would get x equals r cosine theta. And we know that the sine of theta equals y over r. Multiplying both sides by r, you get y equals r sine theta. Now we know that the tangent of theta equals y over x, but we're going to use that relationship to actually find theta. So theta is going to equal the inverse tan of y over x. And always holding true, in a circle, we have this x squared plus y squared equals r squared. If we want to find r, which is, remember, r is the absolute value of r is the distance that our point is away from 0. But just to find the distance itself, it's going to be the square root of x squared plus y squared. So let's come down and do an example. Okay, and I'll come back and review these steps with you. I'm going to jump right into example 2. And the first thing we want to do is we want to plot the point negative 3, 4. Right, so having plotted negative 3 up 4, what we can do is we can find r. We know that r is equal to the square root of x squared plus y squared. So it's going to be negative 3 squared plus 4 squared. So we get the square root of 25 or just 5. Now remember, r can be positive or negative in this case, but since we're focusing on just the angle whose terminal side holds the point negative 3, 4, we're going to just use positive r's here. So we've got our r. Now we need to find theta. To find theta, we know that theta is equal to the inverse tan of y over x. So it's going to be the inverse tan of negative 4/3. All right, so we'll leave our answer in degree mode. So I want to make sure that I'm in degree mode when I find my angle, and I am. So I'm going to quit out of there. We'll do second tan of negative 4 over 3. So that's giving me negative 53, which is a fourth quadrant angle. And so what we want is we want the positive angle whose terminal side is in the second quadrant. So we're going to use this, we'll use the reference angle of positive 53.1 degrees. So if we think of the angle whose terminal side is in the second quadrant, whose reference angle is 53.1 degrees, what we would do to figure that out, we would just take 180 degrees and subtract the 53.1, giving us 126.9 degrees. So we know we have our r and we have our theta. To write negative 3, 4 in polar coordinates, it's going to be 5, 126.9 degrees. Right? So our distance away from Our distance away from the pole is 5, and the angle that we make with the polar axis, right, which is really this horizontal axis here, is 126.9 degrees. All right, let's look at example 2b. We want to convert the ordered pair -1, 0 to polar coordinates. So again, I think it's helpful to graph that point. So -1, 0 would be right here. What we know in this one, you can actually do this without doing a whole lot of work. I mean, you know that r is the distance away from the pole, and the pole is right here. -1, r has to be equal to 1. So we know r is equal to 1. I mean, you can confirm that by doing the square root of -1 squared plus 0 squared, right? You're going to get the square root of 1. The other thing you know here is that you can just visualize what that angle is, right? We know the angle that point, the terminal side there, that point lies on, is 180 degrees from the pole. So your theta is 180 degrees. Your new ordered pair in polar is going to be 1 and 180 degrees. So pause the video and work on student practice number 2. On this problem, we want to leave angles in exact radians, so you shouldn't need to use your calculator for that. And again, angles that we're working with on these problems are going to be between 0 and 2 pi, and we'll round r to the nearest tenth if necessary. And I've plotted for -4. I want to find r by taking the square root of 4 squared plus -4 squared. This would be the square root of 32. And the square root of 32 is approximately 5.7. To find theta, we know theta is equal to the inverse tan of -4 over 4, which is the inverse tan of -1. And so just knowing what we know from the special angles chart that you learned early in the semester, the theta that you're going to get from your calculator or from that chart is going to be -pi over 4. We know that the inverse tan of +1 is pi over 4, and tan is an odd function, so the inverse tan of -1 would be -pi over 4. Now we know that means our reference angle is going to be pi over 4. So we want a fourth quadrant angle whose reference angle is pi over 4. Remember, we would call 2 pi 8 pi over 4. So the angle that we want is going to be 7 pi over 4. So the equivalent to 4 -4 in polar is going to be 5.77 pi over 4. And remember, there's an infinite number of angles that I can use, but we specified in this problem we wanted an angle in radians that's between 0 and 2 pi. Now the next one is another one of those special cases where we really don't need to do a whole lot of work. We just have to work with the knowledge that we have just of the unit circle. 0, 1 falls right on the axis of pi over 2. So I know that I am 1 unit away from the pole, so r is equal to 1 without doing any work. And if I try to do inverse tan of 1 over 0, I'm going to get an error. But I know that the angle already is pi over 2. So because the tangent of pi over 2 is undefined, the calculator really isn't going to help me here. I just know by looking at this that angle is pi over 2. So the equivalent to 0, 1 in polar is going to be 1 pi over 2. All right, in the next video, we're going to convert from polar to rectangular.